the future of automotive. Hope I'm visible. Okay. To the future of automotive maintenance. So first we have to learn about what is vehicle diagnosis. Okay. We have to learn about what is vehicle diagnosis. Okay. So vehicle diagnosis is a process of checking a vehicle's system and components to identify issue and rectify them. This is general vehicle diagnosis. The information is then relayed back to the service provider so they can tell you what will be needed for your car to fix any issue identified during the inspection. Okay. To be identified during the inspection. Outdated or faulty parts could potentially lead to breakdown that are both inconvenient and expensive if they aren't identified early. And if the fault goes undetected, it could lead to a bigger issue in the future. So this is what is your vehicle diagnosis. That means the technician first diagnoses the vehicle, relays the information to the technical team. Remember, service engineers, there are different levels of engineers. Like there will be a technician. Technician will see what are the potential faults. Okay. Okay. So the bush is damaged. Okay. So then the senior technician will say whether the repaired bush will be used or a completely new bush will be used. Okay. So different depending on the level of damage, the senior technician will, you can say, recommend what are the steps to take. And if we don't go for vehicle diagnosis, then what will happen is it may cause potential unidentified breakdown. It can cause potential unidentified breakdown. Okay. Then next is what are the types of vehicle diagnosis? Manual diagnosis. A technician inspects vehicle using specialist tools to diagnose and repair faults. Technically takes longer time and fault is found after breakdown. That means, remember, in manual method, we generally find the fault after breakdown. There is a big breakdown. Okay. Then only we know, okay, so it's a breakdown, so I need to repair my vehicle. Before that, we don't get much information on what is the fault. Another one is data driven. Data driven means what you do is your vehicles have OBD ports, OBD2 ports that is used to relay the information stored from the sensors. Okay. So the technician inspects vehicle sensor, estimate data, estimates the fault and maintenance needs, performs the repair and tuning. So in data driven, the technician already knows, okay, these are the faults, these are the faults, and these are the faults that may happen after some time. So it repairs the faults and maintain those parts so that the fault period will be delayed, or it can be well taken care of in the next servicing time. Okay. That means next servicing will be after 8 months or after 1 year. So for 1 year, this part is going to work. Okay. So if I just repair it, it is going to work. Now, what is an AI? These are the steps of vehicle diagnosis, manual diagnosis and data driven. And what is vehicle diagnosis? Now, what is an AI? Okay. What is an AI? Or artificial intelligence. So we know that artificial intelligence is a collection of technologies that allows machine to perform tasks that typically requires human intelligence. AI uses algorithm data and computational power to simulate human intelligence. Okay. AI works by processing large amount of data and recognizing patterns in the data. It uses a type of artificial neural network known as deep neural networks, which allows a machine to go in depth. to go deep in learning. So generally, what are AIs? AIs are nothing but a huge collection of neurons and fed with lot of data. Okay, processed data. Who is processing the data? Humans are processing the data, feeding it to AI. AI is finding out, or it is learning from there. Okay, it is finding out the required, you can say, it is finding out the required knowledge from that and performs the task. Okay. AI-powered vehicle diagnosis. So using AI, what can we do, or you can say what are the things that can be done in vehicle diagnosis? First is faster diagnosis, up to 90% reduction in diagnosis time. Improved accuracy. AI process vast data quickly and accurately. Okay. It process vast data quickly and accurately. Predictive maintenance. Predicts potential issue before they occur. Okay. Predicts potential issue before they occur. Okay. And better customer experience. Accurate estimates and reduce downtime. So these are the features that we can have in an AI-powered vehicle maintenance. Remember, what a AI can do? AI can do a lot of things. It can see in a detailed way. Okay, it can you can say calculate much faster than humans. Okay, it can perform visual diagnosis. Like we are only we are only okay. So we can say that AIs, what AIs can do? AIs can AIs can calculate much faster. Okay, they can do a lot of things much faster. Okay, than humans. Okay, they can do tasks much faster than humans. So visual inspection, like I was talking about, visual inspection. Visual inspection means like you can fit a AI with ultrasonic sensors. Okay, and we can say different spectrometers. Okay, that human eye doesn't have. And remember, we do what? We capture the image, process the image, and convert it to our understanding. Okay. But we can do very easily that in our AIs. So what is the difference between a traditional and a AI troubleshooting? In AI, it analyzes large data very quickly, reduces diagnostics time by 90%, identify patterns humans may miss. Patterns means like there may be a valve, you can say failure after some time in the engine. How a human may miss it? Because humans will perform visual diagnosis, okay, or since they have to analyze a lot of data, they may miss it. But these patterns can be found out very easily by AI. More accurate diagnosis, more efficient robot. Relies on manual interpretation. Okay, traditional troubleshooting. That means manually you have to check, you have to test, or you have to use the tools to manually check each and every component. Can be time consuming, prone to human error, less accurate diagnosis, less efficient overall. So with this, what happens? With this, a service center. Okay, remember, with this, a service center. Okay, can service vehicles very faster. Like if a service center is servicing 100 vehicles a day, it will increase to 5 to 6 times. Okay. Now it can service 500 vehicles per day with the same setup. Okay. So you can see increase in revenue, increase in profits, increase in everything. So why should not they implement it? 100 vehicles a day means they were going to earn in lakhs or crores. And they can very easily implement AI diagnosis tools. Then what are the tools that AI use? First is your predictive maintenance. Okay. First is your predictive maintenance. Then remote diagnosis, visual recognition. Predictive maintenance means it analyzes sensors and maintenance data to predict issues. Diagnosis issues without physical interpretation is remote diagnosis. Remote diagnosis means, let's say, your vehicle is running in mines, and you are it's a German-made vehicle. It is running in Indian mines. Now, you cannot directly connect, okay, to, or you can say there will not be any German technician or service personnel available, okay, for some kind of repair or diagnosis. So what they do is they can relay those information to server. Okay. And from there, the technician can perform diagnosis. Then visual recognition is there. This is AI-powered camera to identify damage or wear. That means your AIs use cameras, high definition cameras, to find out damage in your vehicle. Then what are the things that we need in order to create an AI-powered vehicle diagnosis? Hardware and software needs. Hardware and software needs powerful computer, AI diagnosis software, vehicle communication interface, integrates with existing system, connected to CRM, okay, inventory management, etc. That means what are the parts needed can also, that means in real time. In real time, the orders will be placed in the inventory. Okay, in real time, what are the service to be done will be relayed to the technician. Okay, it will not be step by step. You can create all those things in using parallel operations, so that your service time or downtime will reduce a lot. Manage vehicle data, collects and stores sensor data, and train staff on AI tools. So these are the things that are needed in order to implement AI diagnosis. First is you need hardware and software, like you need servers, you need workstations where your algorithm will run. But in service centers, remember, in service centers, because we are going for diagnosis, it will not be there in a vehicle. Vehicle is going to collect the information from the sensor. Diagnostic software are there that will be connected to the vehicle, that will diagnose the vehicle and provide the required repair for that. So these are the setups for a service station. First, they need a hardware where they will run the algorithm, softwares for the algorithm, powerful computers and AI diagnosis softwares. Along with that, a vehicle communication. Communication means like OBD communication, okay, your in communication, LAN communication, like this. Integrated with existing systems, connect to CRM and inventory management. It will also be connected to your CRM and inventory management. That means it can also send the required parts. Okay, that is, these are the parts that are needed. So that the inventory, because once it sends those information, inventory has to send those parts to the station. Okay, because it's a continuous task that is going on. So you are going to reduce a lot of time. Manage vehicle data, collects and stores sensor data, maintenance records. That means it collects all the sensor data before and after the vehicle is repaired, okay, and it records. So that again, a second kind of vehicle, if because let's say I am going for Brezza. Brezza, Brezza, lots of Brezzas are there. That is not only one driver will have a one particular car. No. Millions of drivers can have only one particular car. Okay, so collecting the records also helps to repair all those extra vehicles. Then train the staff of AI. So these are the setups required for service stations. Next, using AI for vehicle repair, set up AI diagnostics. Okay, install software, connect vehicle communication. So first is install the software, connect the vehicle, run vehicle diagnosis, connect vehicle input, make, model, and symptoms. Okay. Then understand the AI results, what the AI is giving or what it is saying. It will say, mostly since it is an AI, it will revert back in, you can say, general statements. So like, yes, engine needs repair, valve need brushing, okay, or valve has to be completely replaced, okay, or it can be repaired. Troubleshoot AI tools, check software, hardware, and data. Then future of AI in vehicle repair. So new technologies, autonomous repair systems, cloud-based diagnostics, and neural networks. Okay. What are the impacts? Increased efficiency, reduced costs, improved customer satisfaction. Okay. What are the challenges that the AI will face? High quality data. That means the quality of data may not be that high. Infrastructure investment, it requires a huge infrastructure. Like the centers will first install. Now, that those information should also be relayed to all other service centers. Okay, so that you can create a, you can say, strong network of high quality repair services. You can maintain a strong network of high quality repair services because all your service centers are connected. So for that, you need a very huge investment on infrastructure and data security because personal information may also pass through the servers. So data security should be there. Now, AI implements three ways. What are those? Predictive maintenance, remote diagnosis, and visual recognition. So first is what is predictive maintenance? Okay, predictive maintenance is it uses AI to analyze data from sensors and maintenance records. Maintenance records means till there was no AI, okay, still vehicles were running. So from there we have developed or we have a very good maintenance record when how the vehicle is getting repaired. So if we upload those data to AI, now the AI will train from that data. Remember, humans also works the same way. Like how I start, let's say I am a technician. So first I will repair one vehicle, take the data, then I know what to do on the other vehicle, with little bit of clarity, next, little bit of clarity, next, more clarity. After 50, 60 repairs, I'll be very clear on what are the things that needs to be done. Now I am a professional. Okay. After 50 or 100 repairs, I'll become a professional. That is, I have enough information to perform this task. Okay, or I have enough knowledge to perform this task up to its requirement. Remember, always there are limits. You will not never have all the knowledge, but you have enough knowledge to perform this task. Okay, you can say clearly or up to its need. That means what is needed, you can do it. You have the knowledge. That's all. So if you feed those data to your AI, you can very well train on those data sets and perform. You can say very good repair. Predict potential problems before they happen. Like in your vehicles, you'll be having downtime. Like in mine areas, remember the vehicles are running continuously. Mines are operating continuously. If any one vehicle fails, that means you are losing time. Time is money. Okay, you are losing time, and time is money in mines because the more mining you'll be doing in a day, the more amount of profits will be generated. Okay, drop in or vehicle problem means what will happen is drop in profits, drop in exchange. So a huge, you can say, chain of losses will start to happen. Okay. Hence, reduced downtime is required. For that, predictive maintenance is very much important. That means you can predict that the vehicle is going to fail. So they can plan the maintenance. Okay. Very well you can plan. There will not be any kind of, let's say, today your target is 1000 tons. But some of your vehicles got faulty or they got damaged. Now you may not reach 1000 tons. Okay. So that will, because it is unplanned. Planned was 1000 tons. Now it has become unplanned. So to prevent those things, we need predictive maintenance. Remote diagnosis, that is, the vehicle data is collected, relayed through a server to another, you can say, location where the diagnosis and AI is also doing those diagnosis. So there is no inbuilt AI in the vehicle. Remember, for predictive maintenance, you need a system inside the vehicle. For remote diagnosis is done with along with predictive maintenance. So in remote diagnosis, there is no installed AI in the vehicle. Okay, the AI is doing work over the server. That is your remote diagnosis. Allow mechanics to diagnose issue without physically inspecting the vehicle, reduces the need for in-person inspection. Then visual recognition. Uses AI-powered cameras to identify damage or wear on vehicle parts. Spots issues that may be hard to find for humans to see. It's a visual recognition. Hello. So we have reached the end of this demo. Okay. So I'll again revise what are the things that we have covered. So first is, what is your vehicle diagnosis? Vehicle diagnosis is a process of checking the vehicle. Okay. And identify the issue, rectify them. The collected information is relayed back to the service center so that any other issues that may happen will also be taken care of. Outdated or faulty parts can potentially lead to breakdowns and both inconvenience and expensive if they aren't identified early. And if the fault goes undetected, it could lead to bigger issues in the future. Type of vehicle diagnosis, manual and data driven. Manual means, can say, your technician will be detecting each and every fault manually. It will be detecting each and every fault manually. And data driven means it will be connected from the sensor data. All the sensors are collecting the data, so you read the sensor data and you will find out what are the required faults. So we know what is the AI. AI is a collection of technologies that allows machines to perform tasks that typically requires human intelligence. AI uses algorithm, data, and computational power to simulate human intelligence. AI works by processing large amount of data and recognizing patterns in the data. It uses a type of artificial neural network. Just like human beings, in our brain we have we have neurons. Just like that, there is a mathematical neuron that is used to create AI. And what we do, what are the advantages of AI-powered vehicle diagnosis? Faster diagnosis, improved accuracy, predictive maintenance, better customer experience. Customer will, you can say, that means customer will also be planned. Okay, my vehicle is going to, it needs repair after 15 days, so I can plan it properly. Difference in AI troubleshooting is more quick. Traditional troubleshooting takes time. Reduces time by 90%, time consuming. Identify patterns that humans may miss, prone to human error. More accurate, less accurate. More efficient, less efficient. Okay. So in the future, not in the future actually, it is being implemented now. Okay. No technician is performing any diagnosis. Diagnosis is performed by AI. AI is, can say, given the required instructions that the technicians follow to perform the repair. Okay. Then what are the tools that are used? Predictive maintenance. In predictive maintenance, the AI informs the technicians, okay, these parts may fail after 2 months. The next servicing is after 8 months. So replace these parts. The next, these parts are going to work for next 9 months. Servicing is in 8 months. So don't remove these parts. Leave it or just maintain it. This is predictive maintenance. Okay. A human may, like not remember, when you do this, it becomes a standard. Okay, standard means in India, the same actions will be taken accordingly. In German, the same actions will be taken for the given. But like if there is a lousy service person, he may, okay, this bus is good, I think. Okay, it may run for 1 year. But actually, this bus may run for 7 months. The next servicing is in 8 months. So it may cause fatal, or you can say it may cause failure. Okay. So now once AI is controlling this, it becomes standardized. Remote diagnosis and visual recognition. Then you need hardware and software, powerful computers to set up your AI diagnosis, integrate them with CRM and inventory, manage all the vehicle data that are coming to the service station and leaving the service station, train the staffs on AI. How to use, set up the AI diagnosis, connect it to the vehicle, run the diagnosis, understand the result provided by the AI, and troubleshoot accordingly. And what is the future of this vehicle repair? New technologies, autonomous repair will be there, cloud-based diagnosis and neural networks. Impact, increased efficiency, reduced cost, improved customer satisfaction. Challenges, high quality data, infrastructure investment, and data security. Then in that, what is predictive maintenance? As I have said, that predictive maintenance use sensor data to give information on what are the current state of health of each component. How much component is going to run, but for how much period of time. Okay. It can say valves are going to run for next 5 months. Injector is going to run for next 2 years. It can completely say like this. Remote diagnosis, like if there is no inbuilt, let's say the vehicle is working in an area where there cannot be any kind of electricity. That means everything has to be manual. High voltage area is there. In the power plants where power generation happens, somewhere in regions we cannot run vehicles if there is any kind of electronics. A lot of EMI interference will happen. It may burn your circuits. So there will be no sensor, nothing will be there. Then how to perform the diagnosis? So it is by using visual inspection and remote diagnosis. By using cameras, okay, the AI will find out what can be the problem. Not only with cameras, accelerometers, not accelerometers, manual accelerometers can also be used. Visual recognition. Okay, so this brings us to the end of this webinar demo. So if you have any kind of doubt, you can ask. Rahul Kumar has raised the hand. Hello, Rahul. So there are some questions that you guys have posted. So first is, what work will AI take over from mechanical, electrical, and mechatronics engineers in automotive field? What can people develop the skills using AI tools? Remember, as I have said that AIs will take three things. Okay, dumb, duplicate, and dangerous works. Dumb works means like continuous, like billing. Okay, like you have seen that the person who does the billing, what he does, just scans the QR, enter, bill, you get the bill. Nothing else, just enter. It is a dumb task that can be done very easily by AI. Billing tasks, okay. Setting up the inventory task, okay. Very dumb tasks. You don't need a human. Okay, human intelligence can do much more than that. Okay. So that is a dumb task. No human should be doing that. Okay. Bill entry. Okay. Then you can say inventory management, storekeeping. And these are the things from mechanical engineers. And another thing, so dumb tasks, then dumb duplicate tasks. Duplicate tasks means the same thing if you are performing again and again. Okay. Any task that you are performing again and again, okay, those will be taken from the, you can say, from, that means humans will be removed from that. Again and again means, let's say, I'll just say in a CAD model, okay, you are creating, not CAD model, actually mostly CAD models will not be taken care of by AI, okay, that will be done by humans only. So like this, mostly maintenance and repair tasks will be taken. Designing tasks will be done by humans because that requires a higher level of intelligence. AIs can perform, but not now. That level of, till now it is not. But mostly dumb and duplicate tasks are mostly done in repair and maintenance reasons. Okay. Then dangerous tasks. Dangerous tasks means driving of vehicles. Okay. Like if it is working near a foundry, hot molten iron is there. So better to use AI because a human is not going to work comfortably over there. Just for money, people are going to work, but not comfortably. AI can take it. There is no need for humans to work there. Okay, clear. So these are the areas mostly the AI will be taking. Okay, dumb, duplicate, and dangerous. Remember, any task that is dumb, AI will be taking it. In any task that requires duplication, AI will be taking it. Any task that is dangerous, okay, dangerous and requires less intelligence, AI will take it. Already, all the new automotive comes with ECU electronic controllers. From that, we can diagnose the issue, the car and engine function, safety function. So why it is called AI power? Okay, so till now, you guys have not learned about, okay, how AI works. Okay. If someone asks you, okay, to throw a basketball, let's say someone asks you to, or I'll just ask you one thing, okay, that is, uh, for the second question, a new automotive come up with issue, electronic control unit. I'm saying electronic control unit. From that, we can diagnose the issue that car and engine function. So, issue. So, why we need AI? It is just like someone will ask you, okay, drive the vehicle. You don't know how to ride a two-wheeler. Okay. You don't know how to ride a two-wheeler. Okay, so you have to learn to drive a two-wheeler. You have two ways: drive the two-wheeler directly or calculate how to set the CG, how to sit, what are the positions you required for your leg, okay, what are the positions you required for your hand, what should be the CG, then calculate everything, how first you can go and ride the vehicle. There are two ways. First is drive the vehicle, second is calculate everything and drive the vehicle. Okay. So this is the difference. In issue, everything is calculated. Calculated needs brute force. That means you use brute force to find a value. Like finding a needle in a haystack. Same thing. Okay, you will be using brute force to calculate every sensor's output. But that is not how AI performs. AI is what they do. They don't calculate. Remember, AI is calculate. Remember, the core of AI does not perform any calculation. It is just a pattern recognizer. Just remember that. The core of AI is not calculating anything. It is recognizing patterns. The outside of AI, machine learning, regressions, all those things needs calculation. But once all those calculations are fed to AI to find out or to learn patterns in those calculations. Okay. So your issue cannot find patterns. Your issue cannot know there is a pattern. Hundreds of parameters are there. Your issue cannot know if there is a certain value to each parameter, what will be the result. It does not. It has to calculate everything. Okay. So if you want to perform any kind of diagnosis, take a decision on that diagnosis. Okay. Then electronic control unit needs very high amount of power to perform or to crunch those numbers to get a meaningful output. But AIs can do it very easily because the core of AI is not a calculating machine. It is a pattern recognizing machine. Okay. It does not perform any calculation. Okay. Because for calculation, you need equation. The core of AI is there is no equation to that. It is a very complex not pattern recognizing machine. So it is complex pattern, just like your brain. Your brain is not calculating anything. I have said that. Someone said you to drive the vehicle, to learn it, or to calculate each and every step and drive the vehicle and learn it. Okay. Like you have to learn everything through calculation. Okay, if I take a turn 30-degree, this much centrifugal force, how will I do? Very tedious task. It will take 15 years to learn driving your vehicle if you go with calculating those things. But it will take hardly 2 to 3 days to drive the vehicle two-wheeler if you just drive it how you learn. So ECU is going to crunch numbers to get those data, while AI can recognize those patterns. Without crunching any data, you can know, okay, these are the values, this will be the output. I need proper knowledge related EV and their and what their benefits and which high company can get job. See, EV companies, lot of EV companies are there. Remember, don't go for EV car manufacturing company. EV industry is there, ecosystem is there. Battery manufacturers are there. Your electronic or semiconductor manufacturers are there. Your you can say uh, material required or used in your EV. Those manufacturers are there. Electronic, electrical, lot of ecosystem is there. A very big ecosystem is there that is the driving like. You can get job in any of those things. Good informative demo for my perspective. Glad this demo will get great opportunity and ideology about AI diagnostic.